Hey, Wheaton North, Mr. Yergo here. We're going to talk about solubility graph interpretation. So we've talked about solubility, about unsaturated, supersaturated, and saturated, and we've made a graph in the lab as well for one salt. But we also need to be able to read graphs of several salts to determine solubility. So let's get started. Here is a solubility chart or a solubility graph. It shows the temperature versus the solubility, the grams of solute, so that's like grams of salt that can dissolve in 100 grams of water. Notice that this is per 100 grams. So when we say 90, like right here, that's 90 grams of solute dissolved in 100 grams of water. So how does temperature affect gases solubility? Gas solubility decreases as temperature increases. So it's an inverse relationship. You can see this right here. NH3 is a gas. It decreases as temperature goes up, right? However, solids generally increase in solubility as temperature goes up. So we use KNO3 in the lab, and that increases as temperature goes up. You can dissolve more grams of solute in 100 grams of water at a higher temperature. This is kind of showing the same thing. So as temperature increases for solids, solubility increases, right? This is like if you're dissolving sugar in your tea or something like that. Gases dissolved in liquids decreases, the solubility decreases as temperature increases, okay? Just kind of another way to show it. And that would be applicable to Coke or Pepsi or something like that. At a higher temperature, the bubbles of carbon dioxide come out of solution. It fizzes at a higher temperature because it's less soluble. All right, so this is a simplified graph. It only shows one curve as opposed to the other one I showed you there where it showed several curves, okay? And the line is your point of saturation. So the line represents the most solute you can possibly dissolve in 100 grams of water at a specific temperature. So if you're dissolving less than that, then that would be unsaturated. And if you have dissolved more than that, then that would be supersaturated. If you're right on the line, then it's saturated. So so let's look at 50 grams of solute in 100 grams of water at 75 degrees Celsius. So there's three numbers given. Don't worry about the 100 grams of water for right now because that matches up perfectly with this. So we're dissolving 50 grams of solute at 75 degrees Celsius. So let's find 75 and 50. Where those two meet is right here. So we're below the line. We could still dissolve a lot more solute if we wanted to. We've only dissolved 50. We could dissolve more than 100 before it would become saturated. So this is an unsaturated solution. What about this one? Go ahead and pause the video. Is this supersaturated, saturated, or unsaturated? At 75 degrees Celsius, and we have 120 grams dissolved. That's right on the line, and so that would be a saturated solution. Okay, how about this one? Go ahead and pause the video and figure this one out. 150 grams of solute is all the way up here, and again at 75 degrees it would be right in here, and that is above the line, and so it's supersaturated. How many grams of KNO3 are needed to make a saturated solution in 100 grams of water at 40 degrees Celsius? So now we have several lines on here, and it looks really confusing and cluttered, but we want to just kind of isolate which line we're talking about. It says KNO3, so let's find KNO3 on our graph. It's this curve right here, and let's find 40 degrees Celsius. That's right here, right? So we're going to follow that 40 degree line up until it meets that line, and it meets that line at about 61 grams of KNO3. Okay, 61, 62, somewhere in there. It's a little bit above 60. If you want to make a saturated solution of NH3 at 10 degrees Celsius, how many grams should you dissolve in 150 grams of water? We're still trying to find grams of solute, okay? But this one's a little bit different because it's not giving us per 100 grams. It's giving us per 150 in 150 grams. So this is kind of like the lab where you actually dissolved in 25 grams of water, and then we took it times 4 essentially to figure out how much would dissolve in 100 grams of water. It's going to be a similar calculation here. Let's start with finding our curve. NH3 is right here, right? And we are at 10 degrees Celsius, so let's find 10 degrees Celsius. It's right here. So let's follow that up. It's going to be right at 70 grams. 70 grams of NH3 dissolves in 100 grams of water at 10 degrees Celsius, right? And that's kind of like a proportional relationship. Now, we don't want to know how much dissolves in 100. We want to know how much dissolves in 150. So we have to set this equal in a proportion. What would go on the bottom? 150 or X? 150 would go on the bottom because that's the amount of solvent, right? That's the amount of water. 70 dissolves in 100 grams of water, so how much dissolves in 150 grams of water? And then just solve for X, and X would be 105. Okay, you've actually already seen this sodium acetate demonstration in the last video. What I did is I heated the solution up to 100 degrees, I boiled it, and I dissolved as much as I could. I made it saturated. And then, once it was saturated and completely dissolved, I allowed the solution to cool. So it kind of moves this way on the graph, right? As it cools down to 25 degrees Celsius, room temperature. Now when I give it some sort of activation energy or crystal or something to get it started, it crystallizes down to a saturated solution. Remember, like I said in the other video, not all of the solute comes out, but only enough to make it go back to saturated. So the amount that came out of solution was the difference between 145, because that's how much was dissolved, and it goes down to saturated at that temperature, which is 85 degrees Celsius, or I'm sorry, 85 grams. So the difference between those two is how much came out of solution. There's still 85 grams dissolved. It doesn't recrystallize all the way down to pure water, only down to saturated. Okay, 60 grams of crystal is what would have crystallized out of solution. Let's look at another one of those. Go ahead and pause the video and try and figure this one out on your own. How much will recrystallize if we start with 100 grams of water and a saturated solution, and you change the temperature from 90 degrees to 70 degrees? So we're starting at 90, and it's NH4Cl, so it's right here on this. This is our curve. We're starting at 90, and we cool down to 70. How much would crystallize out? Go ahead and pause the video and write that down. 70 dissolves at 90 degrees, you cool it down, and then the difference, if you recrystallize, only 10 grams would come out of solution because it would go back to saturated. And saturated is 60 grams at 70 degrees, okay? And that's kind of what I'm showing right here, right? 90 degrees saturation is 70 grams. At 70 degrees, when it's cool, a little bit cooler, it can only hold 60 grams of solute. So the difference between the two is 10 grams. I went through a lot of these examples really quickly, so if you're confused, there's a lot of things to look at on these graphs. You kind of have to take your time and go through it slowly. If you're confused on anything, make sure you go back and rewatch me going through examples and get more practice with it. Okay, make sure you bring any questions that you have to class and get those answered, because we're going to be using this solubility chart a lot, and you need to be able to use it relatively quickly. All right, this is Mr. Yergler signing out.